Hi friends, welcome to Hi Friends channel. Today let's we discuss about 8086 architecture. Before going into architecture, let's see some features of the 8086 microprocessor. As we know, 8086 is a 16-bit microprocessor, means it can process 16-bit data at a time. More than that, it cannot be processed. So it is a 16-bit microprocessor, and the maximum clock rate of the 8086 is 5 MHz to 10 MHz. 10 MHz is the maximum clock frequency of 8086, means it can fetch or it can do 10 MHz cycles, 10 MHz cycles at a time per second. That is what the frequency. And next thing, the address which can be given by 8086 is as 20 bits, means it can address approximately 2 power 20 locations. And 8086 consists of 29,000 of transistors, and 8086 is a 40-pin IC. It contains 40 pins inside the IC, and it also made up of 29,000 transistors. It is a huge number. Now let's discuss about 8086 architecture. 8086 architecture contains basically two units. The one is BIU and EU. You can see here BIU and EU. BIU means fetching data. It fetches the data and it stores in this queue. Its work is to fetch the data from the memory and to store in the queue. Whereas you use the execution unit, which executes the instructions and gives the output and stores in these registers. So it is divided into two parts because it is designed for fast calculations. Because 80 its previous version, that is 8085, is a slower than 8086, and it is made to do more fastly the calculations or the instructions. That is how they introduce the pipeline concept. What is pipelining? Pipelining means, you can see they are divided into two parts. This is what called pipelining. Because of pipelining, this unit fetches the data. Its work is to fetch the data, and its work is to execution data. Whereas if we see the previous version, that is 8085 of Intel processor, it contains no pipelining. It does fetching and the execution and decoding full at a time. It is like fetching the data, then second decoding the data, next executing the data, and again fetching the data, decoding, executing. It is a cycle process. But whereas in 8086 we have two units. So first of all, this BIU fetches the data and it stores in this queue, and it is decoded by this control system, and it is executed by this EU, the execution unit, this ALU. ALU performs the all arithmetic and logical unit process. So here the speed has increased, that it executes the data from of 6 bytes, 1 2 3 4 6 5 6 bytes, and as it is a queue, first in first out, the first one or the first byte will be taken by the control system and it decodes and it sends into the ALU for further execution, and it fetches the remaining 5 bytes before itself. Like that, this queue will be always full, and the data which has to be executed after will be taken before itself. So here the BAU is always doing its work, that is fetching the data and filling this queue without keeping it empty. And this execution unit is executing the instructions one by one overall this queue. So there is no gap of relaxation to any of these parts. Whereas in 8086, if the BAU is fetching, this execution is idle, and when it is executing, this BAU is idle. So in that way, time is consuming more. Whereas in 8086 architecture, the time taken by the processing of the unit is very less. So it has very speed. So this is the use of pipelining. So they introduced pipelining in the 8086 architecture for more speed. As we discussed earlier, it has 5 MHz to 10 MHz of clock rate. So it is more faster than the previous versions. So let's discuss the parts of the 8086 architecture. First of all, it contains this special purpose registers. These are registers, and these are the general purpose registers used for data storage, and these are also general purpose special purpose registers. This is the address calculator, which calculates the physical address from the address offset address stored in these segments. And this is the memory is located outside the CPU, that is 8086, because 8086 microprocessor doesn't contain any memory. It fetches the data from the outside the memory and stores in these registers. And this is, as I said before, this is queue which stores the instructions earlier, so that the data will be, the instruction will be executed fast. And this control system decodes the instruction and tells what to do for ALU, or what the function should be doing from that instruction. And ALU executes the operation, that it performs addition, subtraction, multiplication, division, and logical units like AND, OR, XOR, etc. And these are the operands and flags. These are also registers used in 8086. Now let's see the procedure of working of 8086. First of all, for executing the data or the program written by the programmer, first of all we should know the address where the program or the code is situated. So first of all, the address or the base address is stored in these segments, which are known as extra segment, code segment, stack segment, data segment, and index pointer. Index pointer, which shows the index or the offset address of the program. Like if we are in the, if first byte of the instruction is executed And if we like that, we are in the 10th execution, 10th instruction, then it index point, it will increment to the next of the instruction. That is, if we are execute, it is fetching the sixth or the executing the sixth instruction, then it stores index pointer stores the address of the next index. Next, it stores the next data instruction, next address of the instruction. And this address is taken by this accumulator or this ALU. This is the which do calculations. This is the main ALU which does the our main calculations like addition, subtraction, and logical units. But it is also a ALU which calculates only address. It is only calculating address, no other calculations or procedures doing. It calculates the main address or physical address which is present in the memory. It calculates the physical address and goes into the memory to fetch the data from that address. And before going to other things, let's discuss about the buses present in the 8086. 8086 contains 3 buses, that is address bus, data bus, control bus. These buses are used for transferring the data. Address bus is used to transfer the address. As we said earlier, address of 8086 is 20 bytes. 20 bytes. And data is 16 byte. 8086 is 16 byte data microprocessor. So it is a 16 byte microprocessor. And control bus. Control bus is used to control the signals, that if we send a address to the memory, and if we want to read the data, it reads the data, or if we want to write the data, it writes the data. Because this memory is RAM, which is random access memory, it can write and read the data. So it reads the data from the memory, or it writes the data by using the control signals. And control signals contains input, output, and memory signals, which are further discussed. Now it brings the data, it means it reads the data from the memory and brings along this bus. This is data bus. Data bus is a bidirectional bus. It can go and it can come, that is, it can read and write through data bus. But whereas address is only a reading, it only unidirectional, it cannot be bidirectional. And this, it gets the data and stores in this by queue, 6 byte queue. You can see here why only 6 bytes are used in this construction of 8086, because the maximum length of the instruction will be more and more than 6 bytes. There is no instruction which is more than 6 bytes of data. So they have constructed 6 bytes so that it can maximum it can allow one instruction full. So you can see it is 6 byte queue, first in first out. And when the data is stored, or when the data is taken by the data bus and stored here, the controller fetches these instructions one by one from 1, 2, 3 and 6, so on, and it decodes the instruction, and it decodes the work should be done by the ALU. And it takes the data from the data stored in the registers. These are the as I said before, these are the general purpose registers. What are general purpose? These registers are available to programmer. He can read and he can give the data to these registers. These are H, L, BH, BL, CH, CL, DH, DL. Each one is of 8 bytes, 8 bits. We can use together as AX, BX, CX, DX. That is, as it is a 16 bit processor 8086, we can use as 16-bit processor. We can use 16-bit, that is AX. AX means it uses both AL and H, where this AL is lower byte of address, this is higher byte of data. Similarly, BL, BH, CL, CH, DL, DH. And you can see here SP, BP, SI, DA, where SP is stack pointer. Where SP is source pointer, BP is base pointer, SA is source index, and DA is destination index. And these register stores the index pointer registers. As we said here, this IP stores the offset address of the code or data segment. And this SP and BP also stores the base address, whereas SA and DA stores the index or the offset addresses of the data. And this AH, AL, BH, BL, CH, CL, DH, DL are used as general purpose registers for data storing. And when the control system will decode the signal, it sends the signals to this general purpose registers, and the data stored in these registers has been taken by this data bus, and it is sent into ALU. First one is sent into this part, and the second data is sent into this. And these two data are calculated, or when it decodes, it tells the work to be done by ALU. If it want to add, it adds the data. If you want to subtract, it will subtract data. Or if any other logical units like AND, OR will be done by this ALU, and the result will be stored or sent across this bus, because it cannot be stored over any here. So, and this data is again sent into any general purpose registers to store in that H, L, BH, BL, CH, CL, DH, DL, or 16-bit. If we want to 16-bit to data, then we can use AX, BX, CX, DX. So, and this gives the output by calculating the operation, that is addition, subtraction, or any other logical units. And you can see here two boxes saying operands and flags. Why these are used? Yes, operands are used for when there is an emergency of registers or some operations to be done, and there is a need of some register to store a data for temporarily, not permanently. It is for only temporarily used data. Then these operands are used. These are not used by the programmer. It is not meant for programmer. It is used by the processor for its calculations. So it is only temporarily it is stored. It is not stored permanently. If we see, when we exchange two datas, first of all we store a data of one register or the one data in some register, and we copy the other register data into this. But this extra register is what this is called operand. Operands are other registers or the temporary registers which stores the data for temporarily. And flags. Flags play an important role in programming of the 8086 because these flags gives them status of the 8086 or the processes or the output given by the ALU. And flag is a 16-bit register. You can see here flag registers or flags. It is a 16-bit register, and it contains OF, DF, IF, TF, SF, ZF, AF, PF, and CF. What are these? These cross marks are designed for further design or the next architectures or the further development of the 8086. So these are not used by us. And this OF is the overflow flag. This indicates when the result given by the ALU, if it is more than 16 bits, then this OF is set, and when this OF is set, as I said before, flags will give the status of the outputs of the ALU. So when the output of the ALU is more than 16 bits or overflowing, then this overflow flag is set. Set means it is 1. And DF is directional flag. This directional flag is used when there is a operation of strings. When we study strings, when we copy or transfer a string, the instruction is incremented by itself. When this DF is set, that is 1, then it increments from lower order to higher order the data. And when it is reset, that is 0, it takes the data from higher order to lower order. And this IF interrupt flag. This interrupt flag is used for when there is an interrupt occurred by other devices or any input output devices, then this interrupt flag is set, that is 1, set into 1. And when it is reset 0, then there is no interrupt. And this is trap flag. Trap flag is used for execution, or we can say it is used when debugging of the code. When it is set, then the debugging is occurred from one instruction to other instructions, and that means it debugs or the decodes or checks the any errors in the instruction from one instruction, and it goes into other instruction. Like that, it checks all instructions one by one when it is set. When it is reset, it checks as the programmer want. And this is SF is the sign flag. Sign flag gives the output of the result of the ALU is an positive or negative. When it is negative, this sign flag is set into high, that is 1. And when the result of the ALU is positive, it is set into 0, that is it is reset. And ZF, zero flag. Zero flag is set into high when the output is 0, that is 0 is the output of the ALU. It is used when we compare two instructions. And this also a additional flag which is for further design of the processor. And this AF is the auxiliary flag. Auxiliary flag is used or it is set when there is a carry from one nibble one nibble to the other nibble of the bite. As we said, if we do a addition or subtraction, then if there is carry from one nibble, that is first lower bytes of the data to the upper bytes of the data, then this AF is set into high. And PF is the parity flag. Parity flags gives them data about the number of ones and the output of the ALU. If the number of ones is even, then this parity flag is set into high. And if the number of ones is odd, then this parity flag is set into 0 or the reset. And CF is the carry flag. Carry flag, if there is any carry, then this flag is set into high. If we do any additions or subtractions, in additions sometimes we get carry which is more than 16 bits, then it stores sets the flag, or it stores that 1 byte, means it sets 1. When there is no carry, it resets, that is 0. This is all about flags. So flags is 16 bit register. So I covered all topics in 8086 architecture. As I said before, address width of 8086 is 20. That is 20 lines of address are used. That is 2 power 20. That is 1 megabyte. Data can be addressed. That is from 00000h to FFFFFH. This is how the physical address is calculated. See, this is DS stores the base address. This is the base address 5C00H. This H indicates that this is an hexadecimal address. In microprocessors, all the address or the data is in the form of hexadecimal only. And this SI stores the data of the index or the offset address, means here the data is there which we have to take or read or write, and its address is 05C50H. To find this address, we have to multiply this into 10 and we should add this address to get this address. So segment register 05C0 is multiplied by 10, that is 0, and offset address, that is which is stored in SI, that is stack index, source index, and it is added to this, and we get them 05C50H, where H is the hexadecimal. And this is the physical address. You can see this means we want the data from this address, and this is memory. As I said before, memory will be located outside and we have to take the data from the memory. So this is what the architecture of 8086. Thank you for watching. Please subscribe the channel, and for more videos click on subscribe to my channel and click on bell icon to get more videos, and please share and subscribe the channel. By sharing the videos, you can share the knowledge for your friends and others who know you. So please share and please like the video if you like the explanation of mine. Thank you.